got to be a quantity. Second criteria we need for defining a variable well. Okay, so it has to be absolutely crystal clear what quantity you're talking about, meaning you need enough, it needs to be specific, fully specific. Okay, and then what was the last criteria? Units. Okay, so we got to make sure we have a quantity, we got to make sure it's absolutely clear what quantity it's talking about, and then there's units. So x equals the time elapsed since the battery reached a full charge. Is it a quantity? Is it fully specific? Does it have units? No units. This is everything's good except there's no units. Missing units. T equals the time elapsed in minutes. Is it a quantity? Is it fully specific? What's missing? Since when? Starting when? Beginning when? So is it the time elapsed since we started charging the computer? Is it the time elapsed after the computer, the battery is fully charged? Is it the time elapsed after we started using our computer? So those are all different time quantities. So we don't know what time quantity this is talking about because we don't know when we're starting the clock. We don't know when we're going to start and say t equals 0 at this time. Okay, C equals the computer charging. Is it a quantity?
No.
Object, not a quantity. Okay, P equals the percentage of the battery that is charged. Is that a quantity?
Yes.
That's a quantity. Is it specific?
Yes.
Sure. Does it have units?
Percentage, yeah.
Yeah, so we could say in percent, but that's being redundant, right? Percentage is always in percent. So just by saying the percentage, that has the units implied in it. So we don't have to write, again, then in percent. That's percentage, okay? And that's what it says. Valid, totally valid. Okay, N is the number of hours the computer has been charging. Is it a quantity?
Yes.
It's a quantity. Is it specific? Do we know exactly what it's talking about?
Yes.
Yes. Does it have units?
Yes.
Number of hours. Number of hours. Valid. Questions on these? Anybody have a question on those? And all semester long, we come to different situations. We're talking about different kinds of relationships. We're always going to be defining variables, and all semester long, we're going to be practicing defining them well. Because when you get into the middle of a problem, you're doing calculations and you're manipulating formulas, you never want to lose sight of what exactly a specific symbol represents. And that's why we're making such a big deal about this. Okay? Because you get to the end of the problem and you've got C involved or X involved. So you have to know exactly what C or X means, and that's why at the beginning of the problem we define that very well. So there's never a doubt of what those things mean. So let's just get the green bar, because it feels good. There we go, okay? Last chance for questions on this one. So let's try this little exercise. Get maybe with the person next to you. You can talk. Which are quantities? Which ones are quantities? Take a minute. So review the definition of a quantity first. That's what's going to be allow you to answer this correctly. You have to be crystal clear. What exactly is a quantity? So review that definition and then answer. So let's take it a step further. So the ones that are not quantities, here are the possibilities. If it's not a quantity, is it a value? Is it a unit? Is it a measurement? Or is it an object? Okay, so keep going. Okay, see if you got 100%. Here we go. Is meters a quantity? What is it? That's a unit. Is race car a quantity? Is race car a quantity? What is it? Object. Is width a quantity? Yes, width. What is a quantity? A measurable attribute of an object. It's something you can measure about an object. Something you can assign a number to by measuring it. Width is a quantity. It's not specific, but it's still a quantity, okay? 500, is it a quantity? It's just a value, right? So before you came into class, you might have thought 500 was a quantity. That's not our definition. Our definition is something about an object that you can measure, like width. Okay, 17.6 seconds. Quantity? What is that? That's a measurement. That's a measurement. A value with a unit is a specific measurement of a quantity. Acceleration. Quantity. Quantity. The 18,000 fans. Is it a quantity? It's not a quantity. What is it? An object. It just happens to have, as a descriptor, it happens to have a measurement in it. Okay? So you could argue that that's a measurement, but it's really an object. It's the fans. The fans. That's the object. But as its descriptor, it's using the measurement as its descriptor. Okay, so this is the moral of the story. A quantity is a measurable attribute of an object. And remember we said we want to make sure they're well defined. So this width and acceleration, not well defined. So let's make it better. Width of the race car over its front axle. There's a good, well-defined quantity. And acceleration of the race car during the first lap. Those are well-defined. And now if we wanted to say W equals the width of the race car over its front axle, is that a well-defined variable? Why not? Need units. Now if we say W equals the width, what does W mean? W means all the values, the numbers that width takes on. So when you have numbers now, you got to say what your numbers mean. So you need the units. Okay? A equals acceleration of the race car during the last lap in meters per second per second. Okay? So remember, with quantities, it's just that physical attribute. With a variable, now we're talking about assigning different numbers to that variable, so we got to have the units. Okay, so I forgot to collect your homework. You have written homework, right? So here's what you're going to do. Take your whole stack of papers together in your hand like this. Everyone got it? And you're going to fold it right down the middle toward yourself. Vertically. Oh, and if you have fringe here on the left, please take off. Give me a clean left edge first. Clean left edge. All right, and so then you're going to fold it facing yourself. Here's what you're going to do. This is the step that's hard for students. I know this is hard, but students don't do it. You're going to turn the open side to the right. Can you do it? Everybody. Can we bat 100 or 1,000% here? Turn the open side to the right. When I have over 200 students, the details matter. Okay? So now you're holding it in your hand, and it looks like this. Right? Open side to the right. So here's where you can put your heading. On the upper right-hand corner of the back of the last page, it's going to be name. date, and today's the 24th, and 171. That's all I need. And that will always be the date that it's due, not the date that you worked on it, not the date that you turned it in late, although there's no late homework. It's the date that it's due, as assigned on Blackboard, okay? So that will always be that date that you're turning it in class. Questions on the format for, and then you can collect. So what we can do is we can just, maybe it'd be easiest to pass to the nearest end. Pass to the nearest end. And then keep them all, if you would, could you keep them all stacked as you pass? Keep them all stacked on top of each other this way, so we don't have to keep turning them all. Keep them stacked this way. And I'll have rubber bands for you. Questions on this? We good? Okay, so help people, we can reserve and get those other ones. So what we're going to do is we're going to keep practicing this thing about so I have a video here to show you. Left. Okay, what you're going to do is I'm going to keep showing you this video. And you are going to be defining distance and time quantities. For the distance quantities, I want you to define 3 constant distance quantities. Left. And 3 changing distance quantities, and then for the changing ones, we'll go ahead and define variables. And then, time quantities. 3 constant time quantities and 3 changing time quantities, and we'll define variables for the changing time quantities. Okay, so you can do this with your partner. So altogether, 12, you're defining 12 things. Distance quantities, 3 constant, 3 changing. And we're practicing following the criteria, right? And then for time quantities, 3 constant and 3 changing. Left. Okay, you can work with your partner. Go. Left. one thing. Okay, keep going. There should be lots of you talking. Keep going. Where's Topanga? Tell me, a constant distance quantity that you came up with. Total distance ran. Is it a quantity? Is it a quantity? Is it constant? Okay, is it fully specific? So what do we need, what details do we need here to make this fully specific? Do we need a unit? Are we defining a variable? Not defining a variable. So we could put a unit on there, but we don't need a unit. Because now we're just talking about the quantity, just the distance from here to there as a physical thing. We're not assigning a value to it, so we don't necessarily need a unit. But we do need some things to make this more specific. Okay, so total distance ran. So we gotta know, like, from where to where specifically. What are you talking about? So what were you thinking when you said total distance ran? From start to finish of. Okay, so of the race, the total distance ran in the race. All right, we got a constant quantity. Is it fully specific? Okay. Where is Joel? Joel H. Tell me another one.
The total length of the race.
Same thing.
Oh, okay.
So what's another constant distance quantity?
Total length of the bridge.
Total length of the bridge. Is it good?
Yes.
Yeah, it's a quantity. It's specific. We were talking about the length of the bridge. We could say from the start to the end of the bridge, but that's probably kind of a little redundant. And it's constant. Okay, it's not that total length of the bridge is not gonna change. Let's see what else we got here. Where is Brian R? Brian, yeah. The total distance ran in the tunnel. Okay, how do you do? Yeah, it ends up being the same constant quantity as number 2. Okay, total distance ran in the tunnel, except that maybe it wasn't running in a straight line. So okay, so suppose the runners are not running in a perfectly straight line. Would this do it? Would this be good? No, it wouldn't. Why not? Yeah. No, we don't need it. We don't need a unit for the quantity. We don't need a unit for the quantity, but there's something missing here. If we're gonna say the total distance ran in the tunnel, and we're gonna say they didn't run in a straight line, then what? What? Okay. But we're saying they're not. We're saying they're not running in a straight line. There's something very important that's missing here. What's that? Okay, so let's fix it. And I gave you a nice way to distinguish them. Yeah. So which one do you want? Yeah. So if you say the total distance ran in the tunnel, we're saying they ran in a squiggle. They didn't run in a line. Then which person are you talking about? Are you talking about the man or are you talking about the woman? It's crucial there because they each ran a different. It's got to be specific so you know what distance you're talking about. Okay. So changing time quantity or distance quantities, we want to do them as variables. Where is Matthew Garcia?
Here.
You got a variable for me? For distance, a variable.
Distance between the woman and the man.
So what variable do you want? You got to pick a letter for variable.
D.
D. How'd you come up with that? Okay, D equals?
The distance between the man and the woman running.
Distance between the man and the woman. Okay. How do we do?
In meters.
Meters. How do we do now? Changing quantity?
Yes.
It's fully specific?
Yes.
Got units.
Yes.
We're good. Good job. All right. Jacob, B. First. Give me a variable. S equals? How do you do? Is it a quantity?
Yes.
Changing distance quantity?
Yes.
Yep. Fully specific?
Yes.
I don't think so. I'm not sure what he's talking about. Why not? Which person? Which person? So who did you want? Yeah, you got to say who you're talking about. There's two people, and their distance from the start of the bridge is different. So we got to know which person we're talking about. Makes sense. Okay, where's Taylor Underwood? Taylor. Yeah, give me another changing distance variable. Is it a distance quantity that changes? Yeah, so from stride to stride, there's going to be a slight variation in how long her stride is, okay? Is it fully specific? Does it have units? Awesome. Getting the hang of this? Okay, time quantities. Let's do constant first. Where is Logan? Logan O or D? Logan D. Is it a constant time quantity? Fully, is it got enough? Is it specific enough? Sure. Is it spelled right? Okay. Here we go. Talia. Talia O. Oh, Talia D. Talia. You got another constant time quantity we could define in this situation.
The total time elapsed of the whole race the women ran.
Total time for the woman to run the race. Good?
Yep.
Thumbs up. Very good. Gary C. Okay. How about for the man to do something else? What was the total time for the man to
Jog the race?
how about a different span of distance, like within the video? Can you think of it? Through the tunnel. So something different, okay? Total time for the man to run through the tunnel. Constant time quantity. All right, let's define some time variables. So it's actually, so defining the variables is the key we want to focus on. That's what we're going to be doing. Where's Cullen? W. Cullen? Yeah. The variable between the steps and seconds. So we need an amount of time between steps. How do you do? Agree? Something's missing.
Yeah.
Who? Right? There's two runners. And they're going to have time elapsed between steps and seconds. So who do you want, man or the woman? Time elapsed between the man steps and seconds. So the first step may be, 0.3 seconds. The next step might be 0.2 seconds. The next step might be 0.4 seconds. So it's a changing quantity because we're measuring the time from one step to the next. Okay, that works. How about another changing time quantity? Where's Nicole? T.
The time elapsed since the girl entered the tunnel in seconds.
Okay, so in what variable you want to call it? X. Awesome. X equals the time elapsed
Since the woman entered the tunnel in seconds.
since woman entered the tunnel in seconds. How's she do?
Good.
He says good. The rest of you agree? Awesome, right? So why is this a change? Why does X take on many values? How is this a changing time quantity? Because she enters the tunnel, and X equals what? When she enters the tunnel? 0. She enters the tunnel, X equals 0. And now the time starts, right? This value of X is 1 second, then it's 2 seconds, then it's 3 seconds, then it's 7 seconds, then it's 11 seconds since she entered the tunnel. So X is taking on many values. Last one. Who's the lucky winner? Joshua. L. Joshua Lee. Okay, that's 2. So we just want one quantity, right? So, and we've already used X. I'm going to use Y. So Y equals what exact time do you want? Time? I'm sorry, I didn't hear you. Okay, so the time difference for the woman and man to reach the end? How do you do? Why not? He's saying it's a constant quantity. Is that a constant value? Yeah, so everything's great about that. It's totally specific. It's got the right units. It's well defined, except we wanted a changing time quantity. So that's the only thing. So that's good for a constant. We'll move it over there. So as a number 4. But we want a changing quantity. Who's dying to share one? Yes, sir.
Number of breaths the woman took.
But that's not a time quantity. Number of breaths isn't a time quantity. But yeah, that would be a changing quantity that's specific. But who's got a time quantity? Yeah. Time elapsed since woman exited the tunnel. In something new. Minutes. Okay, again, so that will take on, a tenth of a minute, half a minute, 3 minutes, 4 minutes. Okay, again, so we're taking time to do this because we're going to do it all semester, and it's really important that you do this at the beginning of any situation that you're given, because there's going to be quantities, a situation with quantities all over the place. You've got to pinpoint what quantities you're interested in and which ones you're going to call as variables, because they're going to change in the situation. And then we're solving the problem, and then when we get to the end, we know exactly what, if we were pinpointing a particular value of a changing variable, we know exactly what that number means, because we have the good definition. Okay, so let's look at something else here. So here is, I'm defining the variable z as used smartphone memory space in gigabytes. Used smartphone memory space in gigabytes. How did I do defining that variable? You like it? Is it a quantity? Is it fully specific? Does it have units? Yes. Okay, and so I'm showing it here as a bar on the number line. So this the red length of the bar. So the scale on this bar is gigabytes. Okay? And so the red bar is showing the current value of z, right? Z is a variable. Variables vary. Quantities vary in their value. And so right now, how much memory is used up? 4.8, something like that, 4.8. And so you all know you have a smartphone or a computer or a laptop. The amount of used memory space is constantly changing. So this is totally appropriate to put a variable on it. Okay, what is the used memory space now? 2.5. Z equals 2.5. Now Z equals 6. Variables vary. They take on many values. Okay, and so I can show that visually with this bar. Okay, so the red bar is the current value of Z. Okay, now I want to show you another bar on the same scale. So it's still the scale of gigabytes of memory space used. But it's this blue bar, and we'll do it like that. Okay, so now this blue bar, it starts here at what value on the scale? 2.1. And it ends at it looks like 4.6 to me. So the red is the current amount of total memory space used in gigabytes. What might that blue bar be representing? What might it be representing? It starts at 2.1 on the scale and it ends at 4.6 on the scale. Okay, so the memory space taken up by something on your phone, that's true. What else might it represent? Something a little more just general than that. An average? No, not quite an average. So maybe if I put like a little arrow on it like this. So 2.1 starts at 2.1, ends at 4.6. Over the course of time. So what happened over the course of time to the memory space?
Someone started keeping track at 2.1 and then until a certain time, and then at the end of that time it was 4.6.
Okay, right, yeah. So it was 2.1, and then later it was 4.6, which in general represents what in terms of the memory? A change, right? So this is just very broadly, it's just representing, that blue bar is representing a change in the amount of memory space. Or a change in Z. And what is the current change in Z that I'm showing here? 2.5, right? So this, and we denote that as we use a Greek delta. The Greek delta means change in, and it is always followed by a variable because you're talking about the change. You're specifying a change in something, some variable. Okay, so that delta means change in, and in this case, we're showing a delta z of 2.5. And so, what calculation did you do in your head to get 2.5? What did you do to get that number 2.5? So that's what you're saying. Subtract 4.6, right, minus 2.1. That's how you calculate the change in a quantity. 4.6 represents the final value of the quantity. 2.1, the initial value. So delta z equals the final value of z in general minus initial value of z. That's how you calculate the change in the value of a quantity, or the change in a variable. You did subtraction in your head when you looked at that 2.1 and 4.6 and said, oh, it changed, increased by 2.5, and that's the meaning of subtraction here, 4.6 minus 2.1. Okay, so now I'm going to show a different change here. All right, is what I'm showing now different or the same as what I showed before? Is it different or the same? So is it different or the same? This now the change that I'm showing compared to the last change of that I did 4.6 minus 2.1 to get 2.5. It's a trick question, right? What is the same about it? The amount of change is the oh, I don't like that. Oh, that really stinks. I did. Okay, so what do we have here? What was the red one at? Anyone remember? 6. And the blue one was at? Is that what we had? Yeah. Cool. This way. Okay. So, what is the same about those? The amount of change is still 2.5. But it is a different change, right? It's a different change because it's the change now from 0.5 to 3. So this is another way to define a variable. We can define a variable as delta z or delta x, right? Because it can take on many values. But we have to know that when delta z takes on a value, there's different starting values of z at which we could apply that change in z. Okay, so here I'm showing what? I'm showing starting at 0.5 gig, ending at 3 gig for a change of 2.5. Okay, so now here's a scenario. So the red is still current value of memory space used in gigabytes, and the blue is still the change in the memory space in gigabytes. So I want you to think of a scenario that this image may be representing. So what's a scenario that this image may be representing? And I want all the details. I want all the details of what this image is showing. Okay? So with your partner, can you come up with what might this, someone might be showing this, trying to show something, represent something. What are they trying to represent? And be specific. Go. Okay, I'll just call on someone here. Oh, right here in the white shirt. Have I called on you yet?
No, yeah.
Okay. So what did you guys come up with? What do you think?
The blue bar represents the amount of space that is going to be used up by the next section of whatever you download.
Okay, so it represents a download.
Mm-hmm.
Okay, can you give me more specifics about the situation though, given that image though? So given that image, tell me exactly what you could, all the details.
That we had 5.5
Good.
gigabytes of data used, and we are about to use 3.5 more gigabytes.
He said we're at 5.5 gigabytes used on the smartphone, and then what happened?
We used 3.5.
We're gonna download something that's going to require 3.5 gigabytes, and so that's the change. That's the change. So then what happened? Then after this, so then what's the case after this all happens then? We have a new value of z, right?
Yeah.
We have a new value of z. So it's like the red bar was like what it was before, but then after the red bar would be at where? 9. Okay? I just can't show it in both places. So this is the principle that the new value of z, or final value of z, equals the old z or initial z plus the change. I want to do that in red. Should make perfect sense, right? That should make perfect sense. You start at some value of the variable z. If you add whatever the change is, then you're going to get what the new value of the z is. Should make perfect sense. Okay, another example. Last one. That's the best I'm going to do. Okay. So now, go.
So they start out with gigabytes,
What does Z equal? Z equals? Okay, now we want to calculate the change. Delta Z equals what?
2.
Does not equal 2. Final value of Z is 2.1 or 2.2. Initial value.
4.2.
What happens when you subtract?
It's negative.
How can you have negative memory space? How can you have negative memory space? Doesn't make sense. Is that a measure of the memory space used? No, what is it a measure of? The change. The change. Can you have a negative change? It means that the value did what? Decreased. Okay. Can you have a negative value for Z, the red? No. You can't have a negative value for Z, but when it comes to the change in a quantity, a negative value is our mathematical way of showing decrease. It went down by 2. And that happens naturally in the mathematics when you do final minus initial. It works out. Because your final is less than your initial. When you subtract, you're going to get a negative value. And it represents a decrease. Okay? So in this example, Z cannot be negative. You have to have a 0 or positive amount of space used. But any change in Z could be negative, and it means a decrease. It means a decrease. Okay, so check Blackboard for the full details on the homework. There will be web work for Wednesday and a written portion. And then Monday recitation, 10:30. You guys have recitation today. See you Wednesday.